Hello, we're talking about quadratic identities. Now this is a case where if two quadratic expressions are equivalent, and the coefficients of the terms must all be equal. Now that sounds a bit obvious, but basically what you have is if you have something which is a1x squared plus b1x plus c1, we put this sign, and I'll explain that in a second, a2x squared plus b2x plus c2. Now this triple equal sign basically means its equality is maintained regardless of what value of x it is. So as in for any value of x, this is always true. So if this is the case, so you could have two quadratics which are expressed with unknown constants, or you might have expressed in different ways. But what you're saying when this happens is then, I should say if, then a1 is equal to a2, b1 is equal to b2, and c1 is equal to c2. So the basic idea is if I know that two quadratics are equal to each other, sometimes you see this triple equal sign, sometimes not, or just a normal equal sign, but whatever the case, if they're equal to each other, then I know the coefficients must be equal to each other. And so I use that then to solve problems. So we use this to solve problems. So let me show you an example of a typical type of question. So here we go. So find the values of a, b, and c if 2x squared minus 5x plus 7 is equal to 2a, x plus 1 all squared plus b, bracket x plus 1 plus c. Now, what I'm going to do is take this right-hand side, and we're going to expand it out and get it kind of in a form where I can clearly see that it's something times x squared plus something times x plus something, a constant. Now it's going to be a bit fiddly, but let's see how we go. So first thing is I'll have 2a, no, it's actually right hand side, isn't it? Go to the right hand side. Oh, what's going on there? Right hand side is equal to, well, 2a outside. I'm going to expand those brackets. X plus 1 all squared is x squared plus 2x plus 1. Plus, I'm going to expand this brackets. B outside of x plus 1 is just bx plus b. And then we've got plus c there. Next line, I'm going to expand the first set of brackets. 2ax squared plus, well, 2a times 2x is 4ax. Plus 2a times 1 is just 2a. Plus bx plus b plus c. Now what I'm going to do is underline, this is my x squared term. There's no others. Then I've got my x terms. Those are my two x terms. And then, I'm not going to use that, I'm going to use a different color. These are my constant terms because a, b, and c are constants. So if I sort of group those, my first term becomes 2ax squared plus 4ax plus bx plus, I'm just changing the order. Now the final thing is I'm going to factorize the x term so I have a clear single coefficient. So 2ax squared plus 4a plus bx, that's just factorizing the x and putting it on the end instead of the start. And then in brackets, just to show that it's a single constant term, we have this. Now using our result, what we have is the two expressions are equal to each other. So what I can do is look at, okay, well, which part of this is equal to 2, which part is equal to minus 5, and which part's equal to 7. So let's have a look at this. So the 2 is the coefficient of x squared. Well, looking here, I've got 2ax. So therefore, 2a, that's the coefficient of x squared on the right-hand side, is equal to 2, the coefficient of x squared on the left-hand side. So my conclusion is a must be equal to 1. All right, that's the first one. Now what do I have? Well, I've got minus 5. What's minus 5 equal to? Well, it's this one, 4a plus b. So my conclusion is 4a plus b is equal to negative 5. Now, I couldn't solve this, but I have what a is. So if I sub in a equals 1, so 4 times 1 plus b is equal to negative 5. 4 plus b equals negative 5. B is equal to negative 9. So we've got that. Now the last one is, well, I've got 7 And then I have 2a plus b plus c is equal to 7 because they're two quadratics which are equivalent. So 2a plus b plus c is equal to 7. What do I know? Well, a is equal to 1, so b is equal to negative 9. So therefore this becomes 2 times 1 minus 9 plus c equals 7. Well, 2 times 1 minus 9 is negative 7. So c is equal to 14. And so now I have the three things I wanted to find. A is equal to 1, b is equal to negative 9, c is equal to 14. And I found that by using the fact that when I have two quadratics that are equal, the coefficients must be equal. Alright, next thing I want to have a look at, slightly different type of question, but using a similar idea. So let's have a look. Find the equation, that should be question 2, but that's okay. Find the equation of the parabola going through the point 1, 1, 2, 2, and negative 1, 5. Okay, so in general, quadratic has y is equal to ax squared plus bx plus c. Now there's three things I don't know here. I don't know a, I don't know b, and I don't know c. But because I've been given 3 points, I'm going to substitute these 3 points in, and for each one I'll be able to solve it. So let's see how we go. So we sub in 1, 1. So 1 is equal to a times 1 squared plus b times 1 plus c. I'm just taking that point and substituting it in to my expression for ax squared plus bx plus c. So, well, that's just a plus b plus c is equal to 1. Well, that's good. Now we sub into 2. Similar process. So we have 2 is equal to a times 2 squared plus b times 2 plus c. So that's 4a plus 2b plus c. Alright, so that's equal to 2. And then we sub in minus 1, 5. Same process. 5 is equal to a times minus 1 all squared plus b times minus 1 plus c. So if I do this, that's going to be a minus b plus c equals 5. Now what I'm going to do is rewrite the 3 and just sort of line them up, because this is now what I'm going to concentrate on. A plus b plus c is equal to 1. 4a plus 2b plus c is equal to 2. And a minus b plus c is equal to 5. Now, when you have 3 simultaneous equations, basically what you want to do is eliminate 1. You use 1 and 2 to eliminate 1, and then you use 2 and 3 to eliminate the same variable, and then you're going to have 2 new equations which you're going to be able to use to solve simultaneously. So I'm going to do 1 minus, well, no, I'm not going to do, I'm going to do 2 minus 1. So 4a minus a is 3a, 2b minus b is b, c minus c is 0, so I'll put that, 2 minus 1 is 1. So 3a plus b is equal to 1. Alright, now I'm going to do the same thing with 2 and 3, so I'm going to do 2 minus 3. If we do that, we get 4a minus a is 3a, 2b minus b is plus 3b, c minus c is 0, and that's equal to 2 minus 5 is negative 3. So we get 3a plus 3b is equal to negative 3. Divide by 3, we get a plus b equals minus 1. Now I'm going to call these guys 4 and 5. Now I've got 4 and 5, so I'll solve these simultaneously by doing 5, well, I'll do 4 minus 5. What's that going to do? That's going to get rid of my b's. So 3a minus a is 2a, b minus b is 0. And I get the 1 minus minus 1 is equal to 2. 2a is equal to 2. A is equal to 1. Well, once I have 1, then it's okay. Now we're going to sub a equal 1 into, now take your pick. You can do it on either 4 or 5. I'm going to do it into equation 5. 1 plus b equals minus 1, so b is equal to minus 2. And then c, well, I'm going to sub into 1. So substitute a equals 1 and b equals negative 2 into equation number 1, which was a plus b plus c equals 1, which is 1 minus 2 plus c equals 1. 1 minus 1, and so that's just c is equal to 2. And so therefore, equation going through the 3 points of the parabola going through 3 points is a is 1, so 1 times x squared minus 2 times x plus 2 equals y, not 0. That's the quadratic equation. The function is that. And that goes through the 3 points. I'll just pop back up again. That goes through the 3 points, 1, 1, 2, 2, and minus 1, 5. All right, so we've got exercise 9.6 to do a bit of practice on that. Just double checking that that's actually correct. 9.6, have a go, and we're doing okay. Make sure that you're spending time reviewing as well for the exams coming up. Okay, take care, bye.